John Black, super chemist. Yeah, so I'm going to make some table salt, some sodium chloride. One of the ways that I haven't made a salt from is by using a hydroxide and an acid. What I'm doing right now is I'm trying to weigh out 40 grams of sodium hydroxide, and I have in the pot right there about 75 milliliters of water. Okay, and before I get into this, I want to say that I don't condone anyone doing anything or repeating anything in the videos. These are not instructional videos. They're just a vlog of what I'm doing in chemistry, how I'm trying to learn chemistry or whatever. Acid, hydrochloric acid is real bad, corrosive. You need to wear gloves, have a fume hood, all that kind of good stuff for safety. Gloves and goggles and that. Even the sodium hydroxide is a very strong base. You shouldn't be, you should always have your gloves on and gear and all that. So anyways, I got 40 grams of sodium hydroxide. I'm going to put it into 75 milliliters of water. And you know what happens when you do that. Wait, I got a stir bar in there. I'm going to stir it to add it. It heats it up. I ended up adding another 65 milliliters of water or something like that, just because it was taking so long to dissolve. I have here 120 milliliters of hydrochloric acid that I got at the store. Actually, it looks really nice. It's nice and clear. Anyways, remember when you add acid to a water, it gets hot, you know what I mean? Holy shit. Maybe I should drip this in. I don't know if you can see this or not, but I have a SEP funnel up here. It's actually an equalizing funnel, but it's filled up with 120 milliliters of HCO concentrated. And I'm just going to drip it in. Should probably put this in ice. I'm just going to drip it in. Alright, I still have some left. You can see that. But I did a pH test. It's definitely acidic. You can see it's red. So I stopped adding it. Well, here I got it on the heat. It was only at like a pH of 1, so there isn't much HCO in there. I'm going to boil this down. And the thing about table salt is that the difference between, I think it's like 34 grams at 0 degrees and like 39 grams at 100 degrees Celsius. So the difference in solubility, that's for 100 milliliters of water. The difference in solubility is only like 3 or 4 grams. So trying to precip something out, even if you boil it and then take it all the way down to 0, you're only going to get a few grams out. I have 56 grams or 58 grams I made. And I wanted you to realize that the reason why I put excess HCl in there instead of trying to make it exact is because if I have a little bit extra sodium hydroxide, it ruins my thing a little bit because there'll be solids in there. If I have a little bit extra HCl in there, it's not a solid. It's not going to precipitate. If anything, it's going to go up into the air, or it can be washed away at the end. So I'm going to have to get as much water out of there as I can, let it precip as much as I can, and then put it on another long container to help evaporate some more of the water off. Because usually when you recrystallize something, this would be at the point, because as soon as it's boiling pretty much and you can see precip, you need to take it off the heat. But we're going to leave it on the heat, even though there is some precip. Try to get rid of as much water as we can. I keep losing track of the fact that this is on the stove. Oh crap, the water's almost gone from the paint. Oh crap. As you can see, some stuff crystallized out. The only, I mean, if I used lab grade HCl, or I made the HCl myself, there would be zero contaminants in here, except for a little bit HCl, which would be boiled out by now. There is a little bit of contamination from the HCl because I just bought it from the store, like Lowe's. Anyways, I'm going to pour it into here. Throw it here. And we'll just dig that out and throw it in there and give it time to evaporate by nature. Alright, so I made the mistake of, I put this in the oven at 120 degrees Fahrenheit and I forgot about it and went to sleep. So it's all evaporated away, it's just solids now. So there it is in the grit funnel. Basically, I'm just going to get some cold water, put it in there while I have a vacuum on it so it sucks it through, and we'll wash what we have. Sodium chloride doesn't have a hydrate with it, so you don't have to worry about water crystallization. I guess that's one reason why it's a good desiccant. So what we're going to do is just dry this in the oven. So the liquid that I washed this with, I put in here. I let it, pretty much disappear. I threw it into the freezer, and now I'm going to put it into this funnel. You can see it's like one piece. Well, you'll see when I put it in here. There's water in there, it's just frozen. I'm just going to let that take the milk out of there. There it goes. Yeah. Okay, I got this. I'm going to squish it down a little bit. Crunch it. Get all that. Crunch down. You can see it. All that. And you can get that over and down. And we'll wash it with a little bit of water. Okay, we're going to dry this out. Well, this was 39 grams. Remember, I lost track of it. All the water evaporated. So I washed it. I put it in a funnel, washed it with water. That water I evaporated down to this. I don't know if you can see that. And I recrystallized this out after I put it in the freezer. This weighs 12 grams. That's a total of 51 grams. So it should be 58 grams. So that's like an 87% yield or something like that. Keep in mind, if I would have used pure HCl, I could have just evaporated it off from the get-go, everything, and kept everything. I would have had a quantitative yield. I would have had 58 grams exactly. So this is the first reaction everyone should learn, is a base and an acid yields salt water. And that's a kind of generic kind of thing, because there's different kinds of bases and acids. But the most known base and the most known type of acid, add them together and you get salt water. The reason why is because a base has an OH negative, and acid has a H positive. And what's that add up to? H2O, right? Water. And what is salt? Salt is a metal and a non-metal put together ionically. So over here you got your metal cation, you got your non-metal anion. They go together, positive and a negative, right? We used sodium hydroxide, drain cleaner, and hydrochloric acid. This is pretty pure unless it has a little bit of water in it. This has a little bit of impurity. If you would have made this in the, or had lab grade stuff, when you were done with the reaction, you could have just boiled all the water away and everything collected all the salt. But since there is something in the HCl, I'm not sure if it would evaporate away or not. I don't know if they have some kind of salts in there, maybe. I don't know. But that plus that yields sodium chloride, which is table salt, and water, salt water. I want you to notice something. I put the molar masses right below each one because it's a 1-to-1 ratio of everything. Look when you add these two up on this side. It's 76.46 grams for both of these. When you add these two up, they add up to the same thing, 76.46. Because if you start with 76 grams, you're going to end up with 76 grams. Nothing disappeared. Everything just rearranged. Okay? How did I get 36 grams? We did molar weights, and here, let me see. As you can see, HCl at 32.5% is approximately 10 molar. It's actually a little bit more. But 10 moles in a liter means that there's 1 mole in 100 milliliters. And we were doing mole, we were doing 1 mole per whatever. 1 mole of that, 1 mole of that. So we used 100 milliliters. I used 120 just because I wanted to add in some extra acid. Why did I want to add extra acid? I'll go into that in a bit. Got up 120 milliliters because I wanted to have more HCl than NaOH, right? The reason why is because if I have extra NaOH, it's a salt. It's a solid. It's gonna, and I'm trying to make a salt, so I don't want two salts there. I'm trying to recrystallize it, and I'm going to have some impurity. If I have extra HCl, that won't salt out. That's a gas. It's in a liquid. I could just evaporate that HCl away, and I'll be done with it. In our case, we actually had a little bit of impurities, probably because it was store-bought, not lab grade. But you can just add it in. I added 120. I really only added to 100. If you noticed in the video, the last 20 milliliters were stuck inside the subs funnel. The reason why is because the reaction is done once the pH is a 7. All right, now you want to go a little bit past that because, like I said, you want to have a little bit extra HCl. I try to go to a pH of 6, pH of 5. You've seen in the video, I kind of overshot it, and I got to a pH of 1. But that's pretty much it. Anyways, y'all remember, have a great day, and always remember, science is great. And just a little extra thing about something I got here. I haven't had any of these kind of beakers in like a year or so. This is what I've been, well, you can see that crack. That's the one I've been down to basically. So I got some new ones from 1,600, these 150s, 100s, probably 60 or something. What is that? 10 and 5. Check out that little tiny, look how tiny that is. A little tiny 5. Look at it compared to that. I can do a lot more stuff. I've been having to use these Pyrex, but they're not as good. They're really thick. You heat them up, a lot of times they break. So it's really limited.